Hey there, this is the recording for section 612, and you can see I put a few targets here, but namely we're going to be working on the first target, which is learning what a residual is and learning how to graph it and how to interpret it. We'll talk about the term extrapolation, which is in number 2, and then number 3 is, I think, a review. So I think you should be all set there. And I felt that the best math practice here was using appropriate tools strategically because we're going to be using the Desmos graphing calculator quite a bit for this. All right, so let's get started right away on problem 610. It would be good if you had your ebook open because then you can read through the problem. So if you don't have that open, just stop this for just a second and then open that up. Just kind of skim through the problem. All right, and then this will make more sense. All right, but the problem itself has to do with a cereal company, and one of their statisticians has taken some data down about different sized boxes and the amount of cereal that will fit in each in terms of weight. They're probably trying to figure out how much cardboard they need to order and trying to take a look at their bottom line. So here's what I'd like you to do. I'd like you to use the Desmos graphing calculator to put this table in, and then you're going to determine your line of best fit by figuring out an equation that will work here. So please use slope-intercept formula to figure that out, and then go ahead and type that in, and the graph will show right over your points. All right, and then you have a question that you need to answer. So the executives of Battle Creek want a little summary here, so go ahead and give them that summary. The question's here, but it's also in your book. All right, so take some time to do that, and then don't forget to do a screenshot of your graph so I can see the work that you did. If you're totally stuck, I just want you then to listen to my explanation, but then I would like you to actually do the work that I did on Desmos Graphing Calculator just to show me you've practiced it, okay? All right, so here's my work here, and I'll start by showing you my graph. And no, I'm saying my graph with my linear regression. Linear regression is the same as a line of best fit. It's just the term that's used in statistics to say line of best fit. So I'll be using those two terms interchangeably, but it's just good for you to know that. So you can see my graph there on the left and then my line over it. Here's how I found my line. And again, if you had trouble and you wanted to use my data, that's fine, but just make sure you understand how to find an equation using slope-intercept. I used the 2 points 150, 198 and 357, 680 to determine my linear regression. You can see first I found the slope, and you can just look at my calculations there. It's delta y over delta x. And then I used the slope and the point 357, 680 to figure out b. I just plugged everything in and solved for b. All right, now take a look over here at this equation. You can see there's some things that are a little different, right? Whoops, let me go back, sorry. The y has a little hat over it. And in statistics, they do call that a hat. So what that means is that this line is an approximation, right? It's just a line of best fit. It's a linear regression, not an exact situation, right? So just think of that if you see that hat, that this is approximate. It's kind of like a squiggly equals. The other thing that's kind of different in statistics is they often write it as the y-intercept first, and then the slope. So instead of it being y equals mx plus b, it's like it's y equals b plus mx. Okay, I don't know why that's the case. I should look that up, find that out for you, but I'll see what I can find out why they switch it around for statistics. All right, let's move on to my description. Here was my description. I said it was mostly linear. The book says it's slightly curved. All right, I totally agree. It seems slightly curved, which is why I said mostly linear. Either way, whatever, you know, potatoes, potatoes. It's positive for sure. And I said strong association. The book says moderately strong association. I think the book is actually being more accurate there. It's moderately strong. So I like the way they describe that. But it's okay. There's no right or wrong answer. That's sort of subjective, right? Here's my formula. So I would give the executives my math. And then they wanted to know how much a 260-inch squared box would hold. And from my formula, it is 454 grams. All right, now, for 611, I don't want you to write anything down. I want you just to listen to this. This is the introduction of the term residual. All right, so residual is actually the difference between the actual amount and the predicted amount. When you're actually determining the difference, you always start with the actual. So it's the actual amount minus the predicted. Okay, so like a normal way of saying that is, well, how far off was your prediction? That's what a residual is. So how far off were you with this point? How far off were you with this point? So Khan Academy has this picture in some of their work, and you can see that between the linear regression and the actual point, there are 4 units here. The actual is 4 units above your line of best fit. Here, the actual is 2 units below, so it's -2. So if you did the actual minus the predicted, you'd get -2. If you did the actual minus the predicted, you'd get +4. So a residual that's positive, of course, is above the line. A residual that's negative is below the line. And I don't know why this keeps happening, but let me go back. Sorry about that. A very touchy computer here. All right, so what you're supposed to do in 611 then is determine the residual for the 260-inch squared box. All right, so the actual amount that box will hold is 355 grams. My prediction was 454 grams. Being so touchy. Right, so sorry about that. So then when I did the actual minus the predicted, I end up with -99. So my residual for this box is -99. I took the time to graph them, so they're right here. So 264.54, that's my prediction. The actual is down here, 263.55, so you can see that the actual is 99 units below the prediction. So a residual of -99. All right, this is the slide I wanted. Here we go. All right, so for 612, it's your turn. All right, they want you to find the residual for the 471-inch squared box. So please use your own formula. If you were having trouble and are using mine, that's okay too. And please take a look at the number next to the red arrow. That is the actual amount. They are saying to make sure you're including the units for your residual. So make sure that you put that in grams. I think they also wanted you to graph it. Don't worry about graphing it, okay? Just see if you can figure out the residual here, right? The residual is always going to be in terms of y. So whatever the unit is for y, that's going to be the same as the unit for your residual, which is why it's grams in this case. Okay, so stop the video and give this a try. Okay, so here's my work, and I went back to my equation. I could have just looked on my graph, but I like to be really as precise as I can, and the equation's more exact. So I plugged my 471 in here, and you can see with my calculations, my prediction was that the 471 square inch box would hold 945.62 grams. So then when I did the actual minus my prediction, I have a positive 74.38 grams. That's my residual. That means the actual amount is 74.38 grams higher than my prediction, right? All right, moving along. So this is 613. I'm gonna do A. You can watch me just do part A, and then you'll do parts B and C. So let's say the warehouse store wants to offer a supersized 600-inch squared box. The residual is 1,005 grams. By the way, that's a lot. Okay, you can see I've actually already graphed it. What is the actual weight of a 600-inch squared box? Okay, so I went back to my formula, plugged the 600 in this time. My prediction for the 600-inch square box is that it's 1,246.19 grams. But since the residual is 1,005, then the actual must be 1,005 grams higher than my prediction. So that was 2,251.19 grams. All right, that's a huge difference. So I took a look at that, I graphed it, and either that's an outlier, meaning it's just really not working here, or maybe this is not a linear relationship. I'm thinking the slightly curved thing is probably meaning that this is exponential. All right, so that's going to play into questions B and C. All right, so I'd like you to take some time to answer questions B and C, which are right here at the top. B, why do you think the residual is so large? I kind of already gave you my opinion. You can write my opinion down if you want, or if you have an opinion of your own. And then C, interpret the meaning of the slope and the y-intercept in the model, and does the y-intercept make sense? All right, so take some time to answer those two on your paper, and then come back and we'll compare. Okay, so you can see my responses here, and B is not going to be a surprise. I think it might be an exponential function or an exponential relationship. And that's because we're talking about two different dimensions here. And I think as something in 2 dimensions increases, the 3-dimensional measurement of volume is going to increase even more. So that's going to be probably more of an exponential relationship. For C, in my case, the slope is 2.33, meaning that for every inch squared of cardboard, the weight of the cereal grows by 2.33 grams. My y-intercept is negative 151.81. which means if there's no cardboard, then that box can hold negative 151.81 grams of cereal. Okay, does that make sense? No, it does not make sense. Okay, and that's the case sometimes in statistics. You'll find some patterns, but they don't always make sense. I took that little blurb about extrapolating right out of the math notes in your book. You need to be careful about extrapolating things, because sometimes things aren't going to make sense. So I think the point here is, when you're extrapolating, or let's say predicting is another good term for that, or making a guess, it's kind of like a hypothesis, an educated guess. Make sure you're still using your common sense, because sometimes the models don't always fit. All right, I'd like you to try 614 yourself. It's about Armand. He's come up with a relationship between the number of calories in cereal and the amount of sugar in cereal. So I'd like you to use his equation. The questions are A, about a negative residual, and for B, interpreting the slope and y-intercept. So try these 2 problems yourself, and then I'll stop the video, and then when you're ready, start it again and we'll compare. Okay, so I actually took the answers right out of the book this time. This is a little bit small, but let me just read them for you. So for letter A, the actual amount of sugar is less than predicted by the model. So that's a good thing, right? A negative residual is good in this case because less sugar is better for you. For B, his slope was 0.23 or 23 hundredths. So the prediction is an increase of 1 calorie will result in an increase of 23 hundredths grams of sugar. And then the y-intercept is negative 16.9. So a cereal with no calories will have negative 16 and 9/10 grams of sugar. Okay, again, that makes no sense. So a lot of times the y-intercept doesn't make sense in these. So you just kind of keep that in mind. All right, last page. All right, so I just wanted you to look at some of the definitions for extrapolate, because this is something that's used quite a bit in statistics. So they all sort of mean the same thing here, but let's focus on definition 2. By the way, I took this right from dictionary.com. So for number 2, statistics means to estimate the value of a variable outside the tabulated or observed range. That's what we've just been doing. Of course, what we're focusing on is how far our estimates are off, and that's an important thing to consider in statistics, but that's what extrapolate means. It's really making an educated guess about data based on what you've got. Okay, thank you for listening. Don't forget to hand your work in. That just lets me know you listened to the video, and I'll have more assignments on Google Classroom for you, and we'll see you for 613.